Okay, here's the second question in our min-max calculus workshop. And here we go. The question is, determine the value of x that will maximize the volume of this box. But you're given that the surface area equals 34 square centimeters. Well, you're given this 34 square centimeters, you're going to have to make a formula for the surface area of this box, because we can say 34 equals, and you just have to know how to do that. So there's a right-hand side, which is x times h. That's right here. There's another one over here, so there's 2xh that way. Then there's h times 5x. That's the front and the back of this box. There's two of them, so there'd be 10xh there. Okay. And then you've got one more piece here. We've done the bottom. There is the bottom and the top of the whole box, which would be 5x times x. That's the area of the bottom, and the top. So it's 5x squared, but two of them, 2 times 5x squared, to be 10x squared. So that's the first thing. Let's see what it looks like to determine the volume of the surface area of the box. Well, there it is. It's 10x squared. That's the top and the bottom. The 5xh, that's the front and the back. And the right side and the left side's right there. Now, what we have to do, though, is we're going to use a formula for volume. We're going to use the height. We've got to get this formula and make h the subject. So that's what we do. We go 34, we take away 10x squared. This 10xh and 2xh makes 12x. Okay, I can turn on the light so you can see. 10x, so you get 12xh there. Now we want to get h by itself, so we just divide by that 12x. And there we've got a way of writing h. Okay, now it's time for the volume, which is just the three sides times together, x times 5x times the h part here. Okay, so it looks a little bit ugly, but this is all it is. We've got 5x squared gets multiplied by the 34 and the minus 10. That makes 170x squared minus 50x to the fourth. There's an x that will cancel here. This is just going to be x squared divided by x is just x. X to the fourth divided by x is x cubed. We divide the top and bottom by 6, and at least we reduce it into a way of looking at the volume here. Okay. Well, now here's a weird trick. This is looking a little messy, but now once you've got the formula for volume, the next thing you do is you take the derivative. And notice it's all in x here, so we could do that. We've got 85x over 6, and the derivative of that is just 85 over 6. But we go 3 times 25 over 6, and we bring it down 1. Well, 3 times 25 over 6 is 25 over 2, x squared. Well, there's the derivative. Well, we make it equal 0. We make it equal 0, and then multiply everything by 6. It cancels here. 6 over 2 is 3 times 25. Hey, we get 85. 0 equals 85 minus 75x squared. You add 75x squared, divide by 75, take the square root, and that's it. 1.06 centimeters is the value of x. It's going to maximize the volume of this box. That was pretty tricky. We had to, let's just go over it again. You had surface area. You had to work out a formula for the surface area. They told you it was 35. Then solve for the part that's not in x. Make that the subject. See, we figured out what the height is. Then substitute that in to get a volume formula, as ugly as it is. Take the derivative, and whenever you let the derivative equal 0, you're finding in this whatever function it is, you're finding a maximum. So that's what we're trying to get. So then we solve that, and we've got our answer is the maximum is the distance, the value of x. It's going to give us the maximum volume. Okay, well that's question 2 done. So hopefully that'll help when you go to do this thing or look it over kind of carefully. I hope it does. Okay.